So in Chapter 8, Part 2, we're going to extend some of the things that we learned in Part 1. First thing we are going to do is take a look at operations with functions. Now the basic operations, adding, subtracting, multiplying, and dividing, we've already seen in Part 1. Adding and subtracting, you combine like terms. Multiplying, you distribute. Dividing, you factor and cancel common factors. Composition of functions is going to be new. If you look at the bottom here, let me scroll down a little bit. You actually take one function and put it into another function for x. As a reminder, I know you can read, so the definition of function is at the top here, but let me clarify this a little bit if it doesn't quite make sense. If you think about graphing a relationship, if the graph passes the vertical line test, meaning you can put a vertical line through the graph and it only touches the graph once, every possible vertical line, then it's a function. So thinking about some of the functions we've studied already, the absolute value function, any vertical line we place along this graph will only touch it once. There is not any point along that graph where a vertical line would touch it twice. The parabola, same thing. Even the hyperbola that we saw in the last section. So as a reminder, that's the one with the asymptotes. Any vertical line, again, would only touch the graph once. Now you may be wondering about that vertical line. It appears to touch the graph more than once. The reason it looks that way is because the slope at that point is so steep. It's almost vertical, but not quite. So that truly is a function. An example of a graph that is not a function would be something like x equals y squared, which is a sideways parabola. And you can clearly see if we drop a vertical line here, it's touching the graph multiple places. That is a relation, it is not a function. All right, so let's try and quickly go through some of these basic operations that we've already seen before. This is just kind of a review. The notation that I prefer is the notation we see in Part A, where it literally says f of x plus g of x. The notation in Part B, the book uses sometimes, so I needed to introduce it to you so that you understand that it's the same thing. Part B is saying f of x minus g of x. You read it a little bit differently, f minus g of x, but you're asked to perform the same operation. You just subtract the functions. All right, I do have steps over here, even though I really don't think we need them. This is review. We're just combining like terms. If you're subtracting, distribute the negative sign. So we've got f of x plus g of x, which gives us, combining like terms, our 7x squareds cancel. So we've got 12x, and 2 minus 5 is negative 3. Part B, again, we're subtracting, so this time we need to distribute the negative through g of x. F of x stays positive. So notice I changed the signs on both terms in our g function. I distributed the negative as I wrote it down. And then we combine our like terms. So we get negative 14x squared plus 12x plus 7. And the last step is if we are being asked to evaluate, like we are on Part C, we just simply substitute the value for x. That's what's really nice about the function notation, is it tells you exactly what to substitute for x, which will be helpful when we get to the compositions. So you have two options on this one. Substitute 2 into the f function, substitute 2 into the g function, and subtract your answers. Or, since in Part B we already came up with the function for f minus g, we can just substitute it into our expression. So I squared my 2, that's where I got the 4 from. Substituting it in. Negative 14 times 4 is negative 56. 12 times 2 is 24. And then negative 56 plus 24 plus 7 is negative, if I remember correctly, negative 31. No, that is 24 plus 7, so now I need to subtract that from the 56 so we get 25. That's our evaluation.